When we're doing the hypothesis tests to test for a mean, we could find ourselves using either Z or T. The population must be normally distributed. And or, could be both, but we must have one, and or n has to be greater than 30. The thing that determines whether we'll use T or Z is if sigma is known, if they give us the population standard deviation, we'll use Z. If sigma is not known, we'll use T. So you look for the standard deviation and determine from that whether we're going to use Z or T, assuming that it says that it's normally distributed or that there's no reason to think it wouldn't be normally distributed, and or if the sample is greater than 30. In this problem, they want us to find the p-value for the hypothesis test described below. We will, of course, be using StatCrunch to do that. The claim is that for a smartphone carrier's data speeds at airports, the mean is 13 Mbps, which is megabits per second. So this is the claim. Sample size is 22. The test statistic is t equals negative 1.284. Now, they're giving us the test statistic. They're giving us mu and sample size. They want to get the p-value. We cannot do this from, this would be a t-stat. We can't use the t-stat here because we don't have anything about the standard deviation. If we go to calculators, t, we know that our degrees of freedom is going to be the sample size minus 1, so 21. We know that the test statistic is negative 1.284. And so that gives us the probability to the left of this, and since it's a negative t-statistic, it has to either be a left tail or a two-tailed test. The claim is that the mean is equal to 13. There's nothing to suggest here that it would be a one-tailed test. So we're going to have to double the probability. You always double the probability for a two-tailed test because there's actually also the same thing up here at the top. So it would be the same as if we put from negative 1.284 to positive 1.284, and then subtracted that from 1. So we're going to have to work it out for ourselves a bit. We could do 1 minus 0.78687, or 2 times 0.10656. 1 minus 0.78687, is 0.21313. 2 times 0.10656 comes to 0.21312. That would be a rounding error. Let's see what they do. 3 decimal places should be 0.213 in either case. Well done. So when it is a two-tailed test, you can go back through this, either put it in the less than if it's a negative, greater than if it's a positive, and double the p-value, or put it in as a between, putting in both the positive and negative, but there's no way to get this to give us the amount of probability on the outside of it. So you have to subtract it from 1. So without both the mean, the standard deviation, and the sample size, if we don't have all 3 of those, then in order to get a p-value, you have to go into the stat calculator. You would do binomial for a probability, normal for a z-value, and t, of course, for a t-value. So here it says, in a test of the effectiveness of garlic for lowering cholesterol, 49 subjects, this is n, so we notice n is greater than 30, were treated with raw garlic. Cholesterol levels were measured before and after the treatment. The changes before minus after, we would want that to be a positive number, in their levels of LDL cholesterol have a mean of 0.6 and a standard deviation of 0.168. Now this is from the sample. So we have S, not sigma. So we have to use a T. What do the results suggest about the effectiveness of the garlic treatment? Assume that a simple random sample has been selected, identify the null and alternative, the test statistic, the p-value, and state the final conclusion. Okay, so we know that we're going to use T. The null, of course, has to be that where the average difference, so mu is going to be the difference between the two. The null would be that mu is 0. The difference between the before and after is 0. We want to know that the mean change is greater than 0. So our alternative has to be that mu is greater than 0. For the test statistic, let's come over here to t-stats. One sample with summary. The sample mean was 0.6. Sample standard deviation was 1.68. The sample size was 49. We're testing for mu equal to 0 or mu is greater than 0. Compute. The test statistic is the t-stat, so 2.5. The p-value is 0.0079. 3 decimal places, 0.8. Because our p-value is smaller than 0.05, 0.008 is much smaller than 0.05, which would be 0.050. Alpha to 3 decimal places would be 0.050. Our capital P to 3 decimal places is 0.008. This one's bigger, so our probability is smaller than alpha, which means that we will reject the null. This is stating to conclude that the mean of the population of changes, we're going with the alternative, so is greater than 0. So there is sufficient evidence to conclude that the mean of the population of changes is greater than 0. So this should give you everything you need to work these problems. Let me know if you have any trouble. I will see you later.